My name is Oksana Horlock, and today I'm going to give you a bite-sized introduction to the cloud and infrastructure as code. A few words about myself. I work as a site reliability engineer at a company called 6600 that is based in Oxford. I started out as a software developer. I have been working as a software developer I have been working in tech for over 7 years now. I switched to tech from English teaching when I was in my early 30s. And actually, yes, changing careers into tech has been the best career decision that I have ever made. So yeah, I started as a developer and now I'm a site reliability engineer. I'm very passionate about the cloud, infrastructure, learning and sharing, and that's why I am doing this session today. So what will you learn from today's presentation? You will learn about cloud computing and its main concepts, about infrastructure as code and why it's a must-have tool in the tech world, and also about I will also do a demo of how to define and deploy resources to AWS Cloud using a tool called AWS CDK or Cloud Development Kit. Okay, so what is cloud computing then? The official definition is that it's a remote, virtual pool of on-demand shared resources that can be rapidly deployed at scale. If you don't understand some words in this definition, don't worry, we're going to look at them over the next few slides. So basically, with cloud computing, you have the ability to request and use as many of these virtual resources as needed. When you need to scale things up to meet a sharp increase in demand, you can do so. When data is stored in the cloud, it's actually stored on a server somewhere and you can access it via the internet. Cloud servers are located in data centers all over the world. And why is it called the cloud? Well, actually, first it was used as slang. When the internet was in its early stages, technical diagrams used a cloud symbol to represent the internet. And when computing processes began moving to the service and infrastructure part of the internet, people use this phrase, moving to the cloud, as a way of describing this process. The term stuck, and nowadays it is a term that we use to describe this type of computing. Now, cloud computing relies on a technology called virtualization, where digital-only virtual computers operate independently inside a physical computer. And the technical term is a virtual machine. The beauty of virtual machines is that they are very lightweight. So one physical machine can host many virtual machines. One server becomes many servers, and one data center becomes many data centers. So it's very economical to work in this way. If an individual server goes down, it generally doesn't affect the performance of the cloud server, making the system very reliable. Users can connect to the cloud from any device over the internet and can access files and services through either through an app or through their browser. Now, there are different types of clouds that exist. You have a public cloud, and services are offered to multiple customers by a cloud provider. And the vendor essentially rents out use of its hardware to many different customers. A public cloud service runs on remote servers that a provider manages. Customers are usually able to specify the geographic region in which their resources, servers reside. And it's also shared infrastructure, so multiple customers can use, the same server, for example, or the infrastructure bits. Usually you can access your services on the public cloud from anywhere as long as you have an internet connection. Then we have a private cloud. And here systems and services are accessible within an organization. And it is highly secure because resources are shared from distinct pool of resources. And you have more control of the resources. So a public cloud is like renting an apartment, basically, while a private cloud is like renting a house that is more private. And then we have a hybrid cloud, which is a mixture of public and private clouds. Here you have some dedicated resources in a private cloud for predictable workloads, for example. But when you use up all available resources, you can always request more. And in this way, you kind of extend internal the private cloud. So it gives you the benefit of both public and private cloud, and you can choose which one you want to use when appropriate. So hybrid cloud is usually a transitional state for enterprises before moving a service to reside purely in the public cloud. Now, there are also different models of cloud service. So one of the mostly recognized ones, widely recognized forms is software as a service, and it offers users a comprehensive, ready-to-use, fully developed software solution delivered via subscription over the internet. Generally, the cloud service provider will be responsible for managing infrastructure, operating system, the backend, and they will also make sure that the software is operable whenever the customer needs it. It's common for this type of applications to run within a web browser environment, reducing the need for the software to be downloaded and installed. An example of such services are Scribbler, which is a tool for writing, or Slack. Then we have platform as a service. And here, hard and software tools are leased, and they provide you with a cloud platform to develop and create software. So in this case, software developers tend to be the target audience that platform as a service companies target. Now, platform as a service doesn't replace existing infrastructure, but instead it merges itself with other elements such as servers, operating systems, and databases. It offers additional services that complement the standard ones, such as development team collaboration, application design, testing, and development, web integration, and so on. An example of this is, for example, a Google Cloud Engine, Google App Engine, that was designed to support the development and hosting of web applications in Google managed data centers. Here, applications are sandboxed, run, and scaled automatically across multiple servers. Finally, we have the infrastructure as a service, which enables you to construct and control your own servers, data storage facilities, networks, and operating systems. In this way, an infrastructure as a service user bypasses the need to contact physical data centers to run their computers. Instead, the cloud server acts as a host through which a client can access their service either through a dashboard or an API. Infrastructure as a service providers also include services such as log access, monitoring, automation and orchestration, and storage resiliency, which includes things like different recovery modes, backups, and so on. Okay, so examples of cloud service providers are Microsoft Azure and Google Cloud Platform and Amazon Web Services. And there are other things, for example, Alibaba Cloud. The cloud computing has some key characteristics that allow it to become a very powerful service that it is today. Let's go through the main ones. We've got resources on demand, and it's also called self-provisioning. This means that when you want to provision a resource, for example, a server within the cloud, it's almost immediately available to you to allocate where and when you need it. You don't need to wait for hardware to be ordered, installed, connected, and configured before using it. And there's actually no need for human interaction with the service provider. Consumption-based. If you only have an instance running for a couple of hours and then shut it down, you only pay for 2 hours that you were using it for, and that's it. And if you think of it, paying for electricity in your house, you pay only for what you use. You turn the lights off when you don't need them, and that helps to keep costs down. Scalability. Now, cloud computing offers you the ability to rapidly scale your environment's resources. For example, change your server to a more powerful one, adding more memory, etc. Things like data storage capacity, processing power, and networking can also be scaled. When we talk about scalability, we usually talk about vertical scaling and horizontal scaling. Vertical scaling is the concept of adding more resources to an instance that already has resources allocated. So, for example, if you have a server, you add more processing power, you add more memory, and horizontal scaling, where we add additional instances, additional servers that can handle the workload. Then we have high availability, which is the ability of the system to be up and running with very little downtime. And this downtime can be planned or unplanned. And it's usually measured in the percentage of, as a percentage of uptime, and the number of nines that you sometimes see in documentation of different services is commonly used to indicate the degree of its availability. So for example, if a system is available 99.99% of the time, it means that it's down only for around 52 minutes during an entire year. By design, many of the public cloud services are replicated across different geographic zones. And that means that a disruption in one area doesn't result in downtime. So when one zone on one region goes down, you can switch to another. And in this way, you can ensure availability of your services. Then we have elasticity, which is a system's ability to dynamically manage available resources according to the current workload requirements. So elastic system will let you take more of the resources when you need them and allow you to free these resources up when you no longer need the capacity. For example, if you have a website and 100 users log into your website every hour, a single server can easily handle this volume. But for example, what happens when 5,000 users log in at the same time? Can your server handle that? If your existing architecture can quickly and automatically provision new servers to handle this load, it means that it's elastic. Security. Now, cloud providers, of course, attempt to create a secure cloud for their customers, and they try to prevent breaches and maintain public and customer trust. Cloud providers can attempt to avoid cloud security issues, but they cannot control, for example, how customers use the service, what data they add to it, and who has access to it. And that's why when we talk about the cloud, we talk about a shared responsibility model, which delineates what you, as the cloud customer, is responsible for, and what your cloud service provider is responsible for. So usually, cloud service provider is responsible for the security of the cloud. So things like physical facilities, utilities, cables, hardware, and so on. And the customer is responsible for the security in the cloud. And that's network controls, identity and access management, application configuration, and data. Now, when you think of how infrastructure has traditionally been provisioned, you may think of a picture like this, where you would need to employ a person like a network administrator or a systems administrator, and historically has been a time-consuming and costly manual process. With cloud computing, the number of infrastructure components has grown, and more applications are being released to production, and infrastructure needs to be able to be spun up and taken down frequently. Besides, cloud providers offer a lot of possibilities. They offer a lot of different services and many variations within those services that configuring and managing this infrastructure in a secure and efficient way can be a challenge. And that's where infrastructure as code comes into play. Infrastructure as code is a way of managing and provisioning cloud resources through code. Using infrastructure as code, we ensure that all infrastructure conforms to a standard design and needs no manual configuration or maintenance, facilitating scaling infrastructure up or down instantly. Some other reasons why infrastructure as code is important. It allows us to codify our infrastructure requirements into files that are readable by machines. So anyone new to a project can examine the project infrastructure as code and understand how it's configured. By using code to generate infrastructure, the same environment can be recreated multiple times. And this helps to reduce error, and it also keep consistency between environments. With infrastructure as code, your templates can be stored in a version control system such as Git, which allows teams to collaborate on infrastructure, and team members can check out specific versions of code and create their own development or test environments. And because there is no need to wait for someone to provide a server, it can speed up the development and deployment of applications. Keeping full track and trace of deployment ensures that you always know what you have up and what is being used for. This prevents a situation that we sometimes see, that when a server is running somewhere that everyone is afraid to take down because they don't know what it's for, who the owner is, and most probably a developer forgot to destroy the test server and the thing has no function whatsoever, and it still sits there consuming resources and costing money. So infrastructure as code can help avoid situations like that. So it is a must-have tool in the tech world nowadays. Example of infrastructure as code tools are Microsoft Azure Resource Manager, Terraform, which is cloud agnostic infrastructure provisioning tool, which you can use to deploy resources to different cloud providers. Then you have AWS CDK, which is Amazon's own infrastructure provisioning tool, and which is what we are going to use today. A few words about AWS CDK. CDK stands for Cloud Development Kit, and it lets you provision infrastructure in the AWS cloud by using popular programming languages such as Java, Python, TypeScript, C#, and JavaScript, and Go. I've chosen it for the demo because it uses a programming language. So today I'm going to show you how to deploy a static website. Here on a static website, individual web pages include static content. They might also contain client-side scripts, and static website displays the same content or information to all visitors. Its content doesn't change irrespective of user's location, device, etc. And static websites are mostly created using HTML and CSS. So out of scope of the demo is the installation of AWS CDK and the structure of CDK application. And basically the purpose of the demo to show you how to use infrastructure. Now some concepts that we will use during the demo. So a resource is an item of infrastructure. A stack is a collection of related cloud resources. And I am going to use two AWS services. First one is S3, which stands for Simple Storage Service, which basically allows you to store unlimited amount of data. And within S3, we have S3 buckets, which are like file folders within which you can store objects. And these objects consist of data and its descriptive metadata. Another service is used in the demo is IAM, which is Identity and Access Management. It's a web service that helps you securely control access to AWS resources. And there you can set up which user can access what resources, whether they can only read them or they can add, update, or delete them. Within IAM, we have an IAM policy, which is a statement that defines permissions. This policy is attached to a user or to a resource, such as a server, for example, that specifies what is allowed to do. Is it allowed to create something? Is it allowed to delete? And so on. Now, of course, to work with cloud services, you need to create an AWS account. This information is probably more for, if you want to create an experiment with AWS or another cloud provider later. To create resources in the cloud, you need to create an account. with a cloud provider. In this case, it's an AWS account. Then you can log into your account using a username, a password, and multi-factor authentication. Here you can see in the picture a screenshot of a console where you can view different services available, and you can also you also can set programmatic access for a specific user. Now, cloud providers usually have a free tier under which some services are free, but not all of them and not all the time. For example, in AWS, if you are in a free tier, you can only create smaller servers of certain sizes, and you only have about 750 hours to run this service. So you need to really be careful and keep an eye on what you're using and how much for. And it's a good practice to set a billing alarm if you want to experiment with the cloud, which will send you an email when, for example, the amount of money you spend over a certain number. And again, that's why infrastructure as code is good, because you can create resources and you can deploy resources quickly and exactly know what is deployed and what is destroyed. Sorry. Let's start with a demo. I have created an application. I've got a CDK Cloud Development Kit installed here. I can check the version of it. I have also configured programmatic access to my AWS account here. So it knows to create the resources in that specific account. So we're going to create a static site. In AWS, a static website is hosted in an S3 bucket. Here's our stack, which is where we're going to create our resources. First, we will create a bucket. Okay, so we have a bucket class here. We give bucket a name. We specify if this bucket is public or not. If it's public, then you can access it from anywhere, really. If it's private, then it's not available for public access. And we also specify the index document of this website, which is usually index.html. And we also need to add a reference to the S3 here. Sorry. Let's see. Okay. We run CDK deploy. And that should deploy the bucket to my AWS account. Oh, and it doesn't like that. Okay. Maybe CDK. Now let's see if it likes a better. So CDK synth creates a template that is going to be deployed. It's going to be deployed to the AWS account. And let's see. Better now. Oh no. And it always goes wrong during the live session. Right. Okay. Again, maybe.
I have my fingers and toes crossed that this one deploys.
Okay, let's maybe try to destroy the whole thing and try again.
So what does the destroy do?
It destroys all the resources that are created already in the cloud.
Essentially turning on off and then turning back on.
Yes. Okay, let's try again. CDK synth.
And what does the synth command do?
So CDK synth creates a template from the code that you create.
Okay.
Obviously, the cloud won't understand just programming code, no? So it will create a template that is generated here. And this template is in JSON, and it is used behind the scenes. It's used by another service in AWS called CloudFormation, and that is what actually creates the resources. And you can also see the benefit of using the programming language to define resources, because you only have a few lines of code here, but a template is quite big. Okay, I think it's doing it now. Sorry about that.
It's the modern day turn off and turn back on again. The coding version, shall I say? It looks like it's doing it.
Okay.
Yay!
Yay. Okay. Next. So we've created a bucket. Next, we will need to add a policy to this bucket. We add a policy that allows to get object. That means you have read access to the objects. Bucket and for objects allows everything. So star means everything. ARN here means Amazon resource name, which is like a reference to this bucket. So in this case, we allow read access to all the objects in the buckets, and principal is who is allowed to do this. Any principal means anyone, because the website is going to be public and anybody can access it. And here we need another reference to IAM. Finally, in this stack, in this collection of resources, we will need bucket deployment, which deploys the files from your file system to the bucket. You specify what bucket you want to deploy to, and then what you want to deploy. In this case, we want to take files from the website folder that we have here. So this is what is going to go into the bucket. Finally, we have another class here, which is CFN output, and that will spit out the URL to the bucket in the terminal so that we can access it. Now let's do CDK. Okay, so my bucket deployment is missing. So we need to add another reference here. Deployment. Redeployment here. to see the case. Okay, and now CDK deploy again. Okay, in this case, because we have already deployed something in the same stack, in the same template, it shows us what changes it's going to make. We can inspect this and confirm that this is what we expect to be created or updated. When we are happy, we can say yes. And it updates you on the progress. You can see what resources are being created, which ones have completed, and so on. And it's a common thing with other infrastructure as code tools as well. You can see what is happening. By the way, just wanted to mention that the website example has been provided by a codebar student. So thank you very much to them if they are watching. Okay, here we have our bucket URL. Okay, I'm going to give a content warning now because some viewers might find information on the website a bit upsetting. So you may want to look away for about 30 seconds. And here is the website that we have deployed. We can navigate from one place to another. Follow the links and so on. And that's how to deploy our website, a static website to AWS. If you want to destroy, after you don't need the resources anymore, run CDK destroy command as I ran before, and that will destroy all the resources in this stack. Okay, I'm going to start the presentation again. A few final words on why I decided to do this presentation. I think that cloud is the present and the future for other reasons that I outlined in the presentation. More and more companies switch to the cloud computing. And I think knowing some basic things about the cloud is a good thing. And it's highly likely that the company where you're working, or if you haven't got a job yet, when you get your first job, the company might be using cloud services. Infrastructure as code is a very valuable skill in the tech industry these days. I think in companies where it's used, sometimes it's not a requirement to know infrastructure as code, how to use infrastructure as code tools, but I think it's much appreciated if an applicant does know some things about it. I think at codebar, people focus on learning how to code, how to use HTML, CSS, other front-end technologies, I think some Python, I think maybe some SQL as well. And I just wanted to give a bit of an intro into this, another exciting branch of tech, and it's another career path. Obviously, some developers also deal with the cloud infrastructure as code. Some other roles, like my role, site reliability engineer or DevOps engineers, I guess, will work a lot with cloud and infrastructure as code too. And I know that when I studied in tech, I couldn't have thought that I would end up working with infrastructure and with cloud services, but now I can't imagine myself not doing it, at least to some extent. And finally, I just wanted to familiarize you a bit with the cloud and infrastructure as code. I remember 2.5 years ago when I started working in the company where I am now, I had no idea about the cloud and infrastructure as code. So for me, it was a very steep learning curve. And I hope that you, after this presentation, if you didn't know anything about the cloud and infrastructure as code, they won't sound to you as unfamiliar as they did to me 2.5 years ago. Thank you very much. Any questions?
Perfect. Thank you so much. We've got a few more minutes left. So are there any questions for Oksana before we wrap up?
How is it different to Azure? I think someone is asking. To be honest, I don't know, because I've only worked with cloud, with AWS cloud so far. I know that some services are similar. For example, in AWS land, they have a service called Lambda, which allows you to deploy code without needing any service. And I think in Azure, an equivalent is function apps. So that's, yeah. Yes, I think some services are similar, but to be honest, I don't know much about Azure. Hopefully I will learn because I'm interested in other clouds as well. Hopefully an opportunity will come up in the future. AWS, I think somebody mentioned AWS She Builds, an event. I think, yes, I've heard about it. I think it's focused on upskilling people with AWS Cloud. Yes, it's a cloud practitioner. Yes, a cloud practitioner is an AWS certification that helps you get the basic knowledge of how AWS works, again the main concepts and ideas. And I did this certification, and it was very helpful familiarizing myself with the cloud. I'm sure other cloud providers have similar ones.
Someone has also asked, what's the difference between destroy and delete?
The same, I think. Yes, just when we talk about infrastructure as code, I guess the word that is used is destroy. Of course, if you say, oh, I'm going to destroy resources, I'm going to delete resources, I think the meaning is the same.
Okay, well, I think that's all of the questions answered. Thank you so much, Oksana, for coming along and giving this today.
Thank you very much. Thank you.
Bye.